As an extension to aggregate functions, let us go through the details related to manipulating data using functions. This is a vast topic, however, we'll be limiting the discussion with respect to manipulating data using arithmetic operations, using string manipulation functions, and date manipulation functions. We can also change the data types by using type conversion functions such as toString, toInt, toLong, toDouble, toDate, etc. That being said, for all these different data manipulation tasks, we need to use aggregate function, and as part of the aggregate function, we can use project, and we should be able to apply the functions to derive new values from the existing fields. That being said, first let us get into the arithmetic operations. For that, I'll be inserting two documents into a new collection called as sales demo. We can preview the data by saying db.salesDemo find pretty. Now let us try to compute the commission by multiplying the sales amount with the commission percentage. So we have to say 10,000 multiply by 10 and then divide by 100, so that with 10% commission, employee ID 1 will get $1,000 commission. With 5% commission, employee ID 2 will get $600 commission. So we need to use aggregate function here. So db.salesDemo.aggregate. As part of the aggregate, as we are not filtering any data, we don't need to specify match, and also we are not performing any aggregation based on a key, and hence we don't need to specify group. We can directly use project, and as part of the project, we should be able to perform arithmetic operations by using functions such as divide, multiply, etc. So in this case, first we'll be dividing the commission percentage with 100. Whatever value we get, we'll be multiplying with 10,000 and we'll get the commission payment. So here I'm using project. As part of the project, first we need to specify the derived field name. In this case, I'll be specifying it as payment. And then at a higher level, I'll be multiplying with the commission percentage after dividing the commission percentage with 100. So first operation or high level operation which we'll be applying is nothing but multiply. So multiply is a function which can be used to multiply multiple elements in the list as part of the project. So this has to be in curly brace like this. For multiply, we can actually pass list of elements. It can be field or a constant in that list. So we'll be having the field which is nothing but sales, and then a derived field which is nothing but the commission percentage in decimals. So the first element I'll be passing is nothing but sales. As it is list, we can actually specify comma like this. However, when it comes to second element, again it's a derived field, and hence we have to place it in curly brace like this. And the function which we'll be using to derive the value is nothing but divide. Divide also take list of elements. The first element I'll be passing is nothing but commission percentage, and the second element is nothing but 100. So we'll be dividing the commission percentage with 100. It will give us 0.01, which will be multiplied with 10,000, which will give us 1000. Actually, when we divide commission percentage 10 with 100, we'll be getting 0.1. When we multiply 0.1 with 10,000, we'll be getting 1000. Similarly, for this, we'll be getting 600. As we are done with the arithmetic operation, now we can close this curly brace for this curly brace, and then we have to close this curly brace, and then we have to close square bracket and circular bracket for aggregate function and hit enter. I think we have to specify this in double quotes. Now you can see the ID and the payment. If you want to get the employee ID as well along with the payment, you just have to say as part of the projection employee ID 1. Then you will be able to see the employee ID as well. Let's say we don't want to see the ID, and hence we can say underscore ID 0 and then employee ID 1 comma payment. Now we'll be able to see the employee ID along with the payment, which is nothing but the commission payment. So this is how you can actually perform arithmetic operations to derive new values from the existing values. We have to use the aggregate function for that, and we can perform the arithmetic operations as part of the project. That being said, the next set of operations which can be performed are nothing but operations using string manipulation functions. We can convert the case by using two lower. We can actually change the entire field value to lowercase. By using two upper, we can actually convert it into uppercase. We can trim unnecessary characters by using ltrim, rtrim, trim, etc. Trim is used to trim the unnecessary characters on both sides of the string. We can also extract data from the string by using split and slice. Split will convert a string using a particular delimiter into an array, and using slice we can actually get either an element from an array or the range of elements from an array. That being said, let us preview db orders data by saying db.orders.find pretty. You can see the data here. Let's say I just want to get this portion from this field order date, discarding the time. For this we can use substring function. Substring can be used to extract a string from a beginning index to ending index. Also we will try to get the year portion of it by using split and slice. And then when it comes to order status, I want to change the case to lower. So we will try to apply multiple functions in one project as part of aggregate, and we will try to extract the information we are looking for. So here also we need to say aggregate on top of db.orders. We are not going to filter any data, and hence we don't need to use match, and also we are not trying to perform any aggregation here, and hence we don't need to use group. We can directly use project, and we can apply functions and get whatever data we want from these fields. So here I am saying $project. First and foremost, I don't want to see ID, and hence I am saying ID 0. And then I want to see order ID. To see order ID, I can just say order ID colon 1. It will give us the order ID. And then I want to get order date, but I don't want to get the data as is. I just want to extract the date portion and discard the timestamp. For that, I can say order date colon, and then we should be able to use substring function like this. As part of the substring, we can actually pass the date field, which is nothing but order date. And then I want to get from first character till 10th character. So when it comes to the first argument, which is nothing but beginning index, we have to start with 0, 1, 2, 3 based upon from where you want to start. If you want to start from first character, we have to specify 0. If you want to start from second character, you have to specify 1, so on and so forth. However, when it comes to pass the second argument for substring, we have to give the length up to which we want to display. So for example, in this case, if I want to get from first character to 10th character, we have to say 10. It will give this entire portion. If I just want to get this one, then we have to say 0, 1, 2, 3, 4, and then 5, 10. Then it will give us 07-25. In this case, we want to get 0 till 10, and hence we have to specify like this. And then we can close the curly brace for this order date, then comma. The next one, what we want to see is nothing but order year. For this, I want to use split and slice. So first we have to use split. On top of it, we have to use slice. So as slice is a higher level function, we have to say slice first. So slice take list of values as arguments. The first argument can be an array. So in this case, the array has to be created, and the way we can create the array is by using split. So using split, we will actually convert order date into an array using hyphen as delimiter. Then the array will have 4 values. 1 will be this one, 2 will be this one, and 3 will be this one. Actually, it will have 3 values. Okay, so the way you can do it is like this. Again, split actually take list of values, and hence we have to specify this, and this all needs to be passed as part of curly bracket or curly braces. And then we want to get the first element, and hence we have to say 0. So the first value for the slice is nothing but the array, which is computed by splitting using hyphen. And the second argument is nothing but which element we want to fetch. For here, we have to get the first element after splitting this using hyphen. So the logic for the split is nothing but $order date and then hyphen. So hyphen is the character using which we want to split the data. And then we can hit enter. We also want to see order customer ID, and hence we can say order customer ID 1 here. And when it comes to order status, we want to get it in lowercase, and hence we can say order status to lower. As part of the to lower, we can actually pass the field order status like this. So we got all the information the way we want. Now we can close this curly brace for project, and then curly brace for this one, and then square bracket and circular bracket for aggregate, and hit enter. Now you see the data. We got order ID, order customer ID, order date with only the date portion. However, we could not get the order year. That means there is some bug in our code, but we are able to get the order status in lowercase. So let's go through this function and see where it went wrong. Okay, when we actually use slice, the index starts with 1. As we have specified 0, it returned empty value when it comes to year. So I have to say 1 here, and then you should be able to see the order year as a list. Slice also returns a list, even though there is only one element, still it is enclosed in square brackets because it's a list. So this is how you can actually apply functions as part of the project operator to derive new values from the existing values. Now let us also see some of the date manipulation functions here. So as part of the date manipulation functions, we have day of year, which will actually give us the day within a year for the given date. We can actually say $week to get the week of the year, $month to get the month of the year, $year to get the year. So if for today's date, which is nothing but 2019 February 13th, year will be 2019, month will be 2, week will be 6th or 7th week, because this is 6th or 7th week in this year. Day of year will be somewhere around 44, 45. So let us see how we can get this done. So I'm creating a new collection called as date demo. Insert, let's say start date. So it have only one field, which is nothing but start date. And the way you can actually insert data as date is by using new date, and then we can close the curly bracket and circular bracket for insert and hit enter. Now we can say db.datedemo.find pretty, and you can see the start date value as ISO date blah blah blah. Now we want to extract year portion, month portion, as well as day of year and also week of year by using different functions that are available as part of the date manipulation functions. Again, we have to say db.datedemo.aggregate. We can directly use project because we are not filtering for any data, or we are not aggregating by using a key, and hence we can start with project like this. And as part of the project, we can give the field name for each of the value we are going to extract from this date. Let's say year for year. We can use the function called as year. We just have to specify the field name here with $. And then we are getting a derived field called as month. For that, we can actually use month function like this. And then week. For that, we can use week function like this. And then day. For that, we can use day of year function like this. Then we can close the curly brace for project, and then for aggregate, and then square bracket and circular bracket from aggregate and hit enter. Now you can see the year as 2019, month as 2, week as 6, and day as 45. This is how we can actually leverage the functions and get derived values from the existing fields as part of project in aggregate function. So aggregate functions are pretty powerful. However, when it comes to developing applications, we might use the high-level programming languages to come up with aggregations rather than using MongoDB native query-based aggregation framework. However, to troubleshoot the issues and also reconcile the data in case of any data quality issues, this aggregate functions comes very handy, and hence you should be familiar with these aggregate functions as much as you can. But when it comes to application development, we might not use that often, but whenever there are issues with respect to data, if you are familiar with aggregate functions, it can improve productivity quite a bit, and you will be able to troubleshoot the issues much faster.